Hello viewers, welcome to Quick Mathematics. The problem is solve using Crammer's rule, the system of the linear equations 4s plus 3y equal to 13. You have s minus 5y equal to minus 14. Crammer's rule is one of the methods of solving simultaneous equation, and it uses determinant approach of matrix. So let's take the quick solution. So the first thing we do is to label the two equations 4s plus 3y equal to 13 as equation 1, s minus 5y equal to minus 14 as equation 2. In order to obtain the solution, we need to define about three matrices. The first matrix is coefficient matrix, so let it be A. That matrix, we form it using the coefficients of the variables in the equation. So if we take the s column, the coefficient of s in equation 1 and 2 is 4, 1. So this is the s column. If you take the y column, the coefficient of y in equation 1 is 3 and equation 2 is minus 5. So this is the y column. The next matrix is the variable matrix denoted by s. That is the variable you want to look for. So you have s and y in column form. The third matrix is the constant matrix denoted by b. That is the right hand side, and that matrix is 13 minus 14 in column view. So we put the system in matrix form. In matrix form, you have the coefficient matrix multiply the variable matrix equal to the constant matrix, and this is the solution. So the value of s is equal to determinant of a sub s divided by determinant of coefficient matrix. Y is equal to determinant of a sub y divided by determinant of coefficient matrix. So we start by getting determinant of coefficient matrix. You can see the matrix A, we are not using round bracket again, but the symbol of determinant. For 2 by 2 matrix, determinant is difference of the product between the diagonals. So you start with the main diagonal, 4 times minus 5. That is what you have here. The difference is minus the product of the second diagonal, that is 3 times 1. So we have minus 20 minus 3, that is minus 23. Next is determinant of a sub s. What happens is that in the coefficient matrix, the s column is 4, 1. So you replace 4, 1 with the constant matrix 13 minus 14. So we've replaced s column with the constant matrix 13 and minus 14 in order to find determinant of a sub s. Determinant also is difference of the products between the two diagonals, where you start with the main diagonal, that is 13 times minus 5. Difference is minus. The second diagonal is 3 times minus 14. That is what you have here, and that is minus 65 plus 42. You take this minus times this minus become plus. So when you add, you have minus 23. Next is determinant of a sub y. In the same approach, if you go to the coefficient matrix, you replace the y column 3 minus 5 with the constant matrix. So this is y column. It has been replaced with 13 and minus 14. For determinant, you take the difference of the product of the two diagonal. We start with the main one, that is 4 times minus 14, then minus 30 times 1 in this form, and that is minus 56 minus 13. When you subtract, you have minus 69. Therefore, the value of s is equal to minus 23. That is this result divided by the determinant of the coefficient matrix, and that is 1. Then for y, you have determinant of a sub y divided by determinant of coefficient matrix, and you have 3. So this is the determinant, or the Crammer's rule, which uses determinant approach of a matrix in solving system of linear equation. For more updates, for more quick mathematics, follow Voice of Peter Course via YouTube at Peter Course Simplified Maths. To do that, subscribe to this channel, like this video, share the video to your friends, your colleagues, your classmates, your students. You can also follow Voice of Peter Course via Facebook, Instagram at Peter Course Simplified Maths. For questions and inquiries, use the comment section. We attend to all of them. Goodbye.